and it's my pleasure to introduce Sartuk Agarwal, who's going to talk to us about satellite communication channels for Mars missions. Sartuk, take it away.
Yeah, thank you, Ken. Uh, Good evening, everyone. Good morning. I am Sarthak Agarwal from the University of Petroleum Energy Studies, Dehradun, and I'll like take this opportunity to thank Mars Society Convention to allow me to present what I want to do or what I aspire to make Mars missions much better and like progress of humanity as a whole. My topic of research is satellite communication channels for Mars missions. Basically, what made me write about this is like usually we have a delay, a 20-minute delay when of communication when we are like any communication we send from Earth to Mars and back. There is a delay, and that's due to this speed of light limitation, and we actually really can't do anything much about it till now. Uh, but what happens is, as the distance between Earth and Mars, it's not constant. It keeps changing, and sometimes either the sun comes in a way, or the communication. Either the planets are just too far away to receive any good enough communication, and we are using radio waves. So uh, that is why, like, it's not good right now. And if we plan to go send humans at Mars, uh, this kind of communication won't cut it. So what we need is to have a consistent, redundant, and an efficient system that can ensure at least a way which we can adapt to. So we cannot do something about the delay, like too much about the delay of communication, but at least we'll be able to work with something. So what I propose to do is use Lagrange points. Lagrange points are like due to the these are like five these 5 points are these gravitational, like due to the gravity between the Earth and Sun, like as shown in the image on the left side. These points where we can put satellites over there and they'll stay over there due to the gravitational influence of the sun and the earth. They'll keep it's balanced, so they'll it's an oversimplification of the thing, and they'll stay. And so we will be having similar points, Lagrange points, between earth, Mars, and sun, so that we can have a satellite constellation which will be like a consistent satellite which will cover the entire all places where possible scenario where earth and Mars can be. They can, right, like even right now from October 2nd to the October 17 18, right now for all Mars missions, they were the communication was already pre-sent before a blackout, because Mars was like sun was coming between earth and Mars. So there was no way for any radio wave signal to reach to Mars. So all instructions had to be present to the to the Perseverance rovers and Curiosity rover. So what this constellation will do is ensure that a constant communication or data link is established between both the planets, and this can be expand, and this has a potential to be expanded uh, in the future as we can. And it's like this is the most promising thing that can we do. Like obviously the delays will increase, they unless and until we find a way to like transmit any information faster than the speed of light. And what right now we can do is to send as much data as possible at once. So we'll planning so I plan to use laser based communication, which can offer 10 to 100 times more amount of data that can be sent at the once. What uh, as compared to radio wave X-band communication, which we use right now. Where this kind of communication is right now being demonstrated by NASA's LCRD-3 mission, and it was sent, which will test this kind of laser-based communication, sending data at around 1.2 gigabits per second. Uh, Uplink, and in 2022, another such laser communication module will be sent to the International Space Station to test and uh, to make an array which can test data communication within space, laser-based communication within space. And since it's using infrared, it is much more accurate than radio waves lasers. Although uh, calibration will be a challenge, but with our technology, current technology, we can work towards making it much more precise and have a redundancy as well for any data that we send. And this will be the future. I think this will be the future of how we communicate between two planets when humanity populates the planet. Thank you.